This is question 45 of section 1 from the 2018 ENGAA paper. So in this question we're given point A, B and C, and we're told A lies at -3, 2, B at 1, 3 and C at -1, U, where U is some real number. And we're also told the distance between A and C is equal to 2 times the distance between A and B. And we're asked to find the possible values of U. So how do we go about this? Well, we could draw a diagram, but in all honesty, having had a brief look at it, it isn't particularly helpful. It's just the sketch doesn't shed much light on what's going on. But the thing is, this question concerns the distance between A and B and distance between A and C. So the first logical port of call may be to try and get expressions for this distance AB and distance AC. So we'll start with AB because we know exactly where both those points are, so we should just get a number out. So by Pythagoras, distance between AB squared is equal to 1 minus -3, so I had a difference between 1 and -3, which is 4 squared, and a similar plus 3 minus 2 all squared. So 1 minus -3 is 4, so that's 16 plus 1, so 4 squared plus 1 squared, comes to 17. And from this we can work out the distance AB if we want, just by taking the square root, but we won't for now. And we can do similar for AC squared. So there's a little bit more awkward because we've got the unknown. But again, the difference between -1 and -3 whole squared plus U minus 2, which is the difference between U and 2, obviously, squared. And that becomes 4 plus U squared minus 4U plus 4 by expanding this out to get U squared minus 4U plus 4, and then this 4 just comes from this squared. And then collecting the terms, U squared minus 4U plus 8. So we've got these two expressions, and from this we could work out the distance AB and AC fairly easily. So we've got both these distance values, and we want to basically sub them into here and say for what values of U is this true. But the thing is, subbing this in isn't particularly easy because the square root of this is unclear to say the least, and square root of 17 is horrible to deal with. But the thing is, we don't have to directly deal with this, because this is true. This sign means equivalent. So if the distance AC is equal to 2 times the distance AB, then certainly this will be true. Distance AC squared is equal to 4AB squared. And similarly the other way, because these are all positive quantities because they're distances. So instead of trying to find U to satisfy this, we can find U to satisfy this, which is far easier because we've already got expressions for these two things in nice forms. So equating them, we get this. U squared minus 4U plus 8 from over here is equal to 4 times the distance AB squared, which is 17. 4 times 17 is 68. And so if we bring the 68 over, we get a standard quadratic. So we can factorise this as this, because minus 10 times 6 is minus 60, and minus 10 plus 6 is minus 4, so this does work. And from this, clearly, for the quadratic, you get U equals 10 or U equals minus 6. Are both these solutions valid because we're working with distances? Well, yes, because U isn't a distance, U is just a coordinate. And so U can happily be negative and we're absolutely fine. So from this, we deduce that our answer is D, as this matches with option D in the multiple choice.